the next section of this motion is what's known as kinematics, and as it says there, it's the study of motion. So it involves position, displacement, velocity, acceleration and time. So it's a study of motion. It's basically what's happening. Right? So not why or anything like that, it's what's happening. So, you know, where it is, how far it's moved, what direction, how fast, that sort of stuff, how long, all those sorts of things. Alright, so the first thing is position. So position is, in your notes there, you've got the definition with the missing letter, word I should say. So position of objects tells us where the object is located. Alright, so it tells us where. The symbol that we use for it is an X, and the unit is meters. So it's so many meters from a particular zero position, wherever that may be. Alright, so that's position. Then of course something could change its position, and that's what we call displacement. Alright, so displacement of an object is the change in position and the direction of that change. Alright, so in your notes, the displacement object is the change in its position and the direction of that change. Alright, so you could think about this diagram. Alright, so here's the diagram. So you've got the initial position and then the final position there. So it's changed its position, it's gone from there to there. And so the displacement is that how far, and also in what that direction might be, is the displacement. So displacement then is a vector, because it has a size component, the distance, and also the direction. Now the thing about the displacement, it's like the straight line, boom, boom. So it's independent of how you actually got somewhere. So, you know, to get from there, you could have done all sorts of things, you know, like that. You could have followed that pathway, but the displacement is that green line straight from one to the other. So in your notes, it's independent of how you got there. Alright, so as I already mentioned back here, it's the change in position, and so if we're writing that as the change in position, so we use the symbol, the delta, to represent change. So that's the change. And so the change in position then in your notes says that. So the change in position will be the final position minus the initial position. Alright, so that's where we're doing our vector stuff in this first part. That's why we're doing that, because we're going to be looking at these sorts of things. Alright, so because it's a vector, already mentioned that, so it has a size. Another word for size is magnitude. And a direction. Alright, magnitude, how far you went, and the direction, what direction you had to go to get there. So displacement in your notes, there's a few different symbols. So the delta X, the bold X, X with the arrow. Sometimes you might even see D with an arrow. Delta X, that might have an arrow. Alright, so a few different ways that you can write it. Alright, example. So let's have a look at. Alright, Sue travels 8 metres in a northerly direction, followed by another 6 in the easterly direction. What is her distance travelled? Alright, so if north's up there, so she goes 8 in the northerly direction, and then she turns the corner and goes 6 in the easterly direction, and so she starts here and she finishes up there. Okay, so you've got to read these carefully. Distance. Distance is the actual pathway. So the distance here means the pathway. Alright, so along that pathway, what distance did she walk? Well, that's just simply 8 plus 6 equals 14 metres is what she walked. Now, if we were asked about displacement, then her displacement, well, that's something different. So her displacement is this vector there, the green one that I've just drawn. So let's call that y. Actually, let's call it delta x. Let's be a bit better than that. And then, of course, we need to know direction. So because this 8 metres is north, then we turn around this distance, this direction here, call it theta. In the notes on the website I've used different symbols, but alright, so what do we know? Well, north and east are at 90 degrees to each other, so we know that much. So her displacement is her change in position, and the change in position is that green vector. So her change in position, and then as Pythagoras tells us, the change in position squared would be 8 squared plus 6 squared. So the change in position squared would be 64 plus 36, which works out to be 100. So if we square root 100, so the change in position, the size part, the magnitude part of it is 10 metres. Alright, the angle bit. Alright, the angle bit. Well, the angle is that orange one there, and we've got the opposite, the 6 metres, and the adjacent. So to find the angle, we'll do tan minus 1, because that tan is opposite over adjacent, 6 over 8. And when you put that in your calculator, you get 36.9 degrees. Alright, so her displacement vector is 10 metres, and the direction is north 36.9 degrees towards the east. Alright, so distance, displacement, two different things. Alright, so you could also involved in there is if you've got a displacement, so you're going from there to there, depending on how long it takes you, well, if it's going to be a shorter time, you've got to go faster, of course. So that leads us to a thing called velocity. Alright, so velocity is a quantity that tells us how fast an object is going. Alright, so that's your word in your notes. And also the direction. Alright, the direction of travel. Alright, so they're the missing bits in your your notes there. So because it's got a how fast bit, so that's a magnitude, and a direction bit, then it would be velocity then is a vector. Alright, so to indicate that it's a vector we use V and then the arrow up the top for the vector. Alright, so the next bit in your notes is, so it's the displacement. Oops, gone too far. So the displacement's the thing we're interested in because it has a size part and a direction. So, but it's also, because it's the how fast bit, depends on how long it takes us. So an object velocity, we need the displacement, and we also need the time, how long it took. Alright, so under there in your notes in that, so it should say, thus the velocity is the change in position, which is our displacement, over the time. So if we, strictly speaking, should have vector signs on that, which I think, and so that's the final position minus the initial position, xf minus xi, or x2 minus x1 as I've got in the notes on the website, over t. Now, what this actually tells us is it really doesn't tell us the velocity at a particular time. What it tells us is the average, and that's velocity over the journey. Alright, so the average velocity over the journey is what this tells us. Alright, because it may be speeding up, slowing down, but average velocity it doesn't take, because that displacement, we don't know how we actually got there, it doesn't take that into account, but that's alright, it's the average velocity over the journey, over that time. Alright, so the units, we just use the units of displacement, which is metres, and the units for time, metres per second, or we can also write it ms to the -1, both of those are interchangeable. Alright, now the next bit there is that velocity should not be confused with speed. Alright, so velocity should not be confused with speed. Alright, so speed, velocity is a vector, speed is a scalar, and to work out speed, speed is actually the distance, not, alright, so the actual distance that you travelled over the time it took. So your velocity and your speed will more than likely be different. Now there's a little note in there in your in the notes there about metres per second and kilometres per hour. So the international units are metres per second, and so metres per second, if you want to go to kilometres per hour, then what you need to do is you need to multiply by 3.6. Alright, so metres per second to kilometres per hour, you times by 3.6, and if you want to go the other way, well, you would do the opposite. Alright, so any questions in your text which have kilometres per hour, or the times different, times in second, and you got kilometres or something like that, you need to change. So there's the conversion. Alright, let's have a look at an example of velocity, and in this example we'll look at a journey and we'll look at the speed and the velocity and have a look at those. Alright, so here's his thing. Zoe walks 300 metres north and 400 metres east. Takes 8 minutes for the journey. Find her average speed. Alright, so let's draw a diagram. So she's north that way, and so she goes 300 north, and she goes 400 to the east. And the time, 8 minutes. Now time has to be in seconds. So 8 times 60, 6 8s are 48, so 480 seconds, alright? Alright, metres and seconds are the standard units, so we need to work in that. Alright, so speed is the distance over the time. So the distance, well, she actually walks 300 plus 400 in 480 seconds. And 300 plus 400 is 700 in 480 seconds. And when you do that on your calculator, you get that that's 1.46, and the units are metres per second. All right. Part B is asking about her average velocity. So remember, she remember she went 300 north. So again, I've got north up the page there. She went 300 north and then 400 east. So her displacement vector is that one there. So that is our delta x. It's that vector there. And then we need that angle. Why do we need that? We need that because the velocity is the displacement, the change in position, over the time that it takes. Alright, so our old friend Pythagoras says that delta x squared would be 300 squared plus 400 squared. Do that on your calculator, and delta x squared is, and add it all together at the same time, 250,000. And so when you square root that, the change in position is 500 metres. Alright, the displacement, we need the angle, don't we? So we need the angle, and tan minus 1 of the opposite, which is 400, over the adjacent, which is 300. And you do that on your calculator, and you get 53.1 degrees. Alright, so the displacement then is 500 metres north, 53.1 degrees towards the east. Alright, so we were asked about the average velocity, so displacement over time. So our average velocity then would be the displacement 500 over the time 480. It's the size part. When you do that on your calculator, it's 1.04 metres per second. And the direction, of course, is north, 53.1 degrees towards the east. It's the same direction as the direction of the displacement. All right, so as you can see by looking at those two, the answers are a little bit different. All right, and that reason is that there's a difference between the distance travelled and the displacement. All right, so if there's anything there that you want to ask, make sure you do ask. Also on the website there. Alright, there's a video on the website there which talks a bit more about those, so have a look at that video. And of course, as I already said, if there's any questions, make sure you ask.